This code detailed explanation of the PCA workflow. This code walks through an application of principal component analysis PCA to the MNIST test datasets. Below is a thorough breakdown of every section including the libraries used, their purposes and the details of the data transformation and visualization. Libraries overview. First, NumPy provides support for a numerical computational such as handling multiple dimensional arrays and performing matrix operations. Used here for reshaping image data, performing matrix multiplication, and handling covariance matrices. Pandas offer tools for data manipulation and analysis. Used here to load dataset, manipulate tabular data, and analyze data used in built-in functions. Matplotlib, a visualization library. Specific pyplot is used for plotting images and scatter plots. Seaborn, used on the top of Matplotlib to simplify creating attractive statistical visualizations, used for creating color-coded scatter plots based on PCA results. Step-by-step breakdowns. Data loading. Purpose: reads the MNST test data into Panda data frame called raw data. Structure: the data contains 10,000 rows and 785 columns. The first column, label the digit 0 to 9, represents by the corresponding images. Image Remaining columns pixel values for 28 to 28 grayscale images, where each value ranges from 0 black to 255 white. Data pre-processing. Purpose: extract the first 10,000 raw of the label column into a variable 1. Result: contains the labels for the first 10,000 images. Purpose: removes the label column and it's not a feature and selects the first 1000 rows of pixel data. Visualization of a random image. Selecting a random image. Purpose: generate a random index between 10 to 10,000, 0 to 10,000. Select a random image. Extract image data. Select the row at the random data index from R data. Convert the raw data to NumPy array and reshape it into 28 into 28 matrices. Display images. Visualize plt.im show plt.im show displays the visualizes the matrices of a grayscale images. plt.show renders the image plot. Standardizing the data. Standardizes the pixel data to have 0 means a unit variance, which is essential for PCA to ensure all features are treated equally. Stand underscore data is standardized version of our data with shape 100784. The purpose of this code is first, dimensionality reduction reduces the 784 features of MNIST data to two principal components while retaining most variance. Visualization displays the data in 2D shape, making it easier to interpret cluster based on label digit. Understanding PCA demonstrate how PCA transforms from high dimensional data into a lower dimensional space. This code is an excellent example of pre-processing applying PCA and visualizing result for data analysis and pattern recognition. The fifth is the covariance matrix calculation. Here, purpose computes the covariance matrix using the formula standardized data matrix with shape 1000 and 784, transport matrix with shape 784 and 100. As a result, the 784 into 784 matrix capturing features relationships performs eigen decomposition on the covariance matrix. Extract the two largest eigenvalues and their corresponding eigenvectors. Represents the variance captured by the top two principal components, directions, and associated with the top eigenvalues. Project the original data onto the top two principal components. Dimensionality reduction is a 2 into 1000 matrix representing the reduced data, the final data set. Final data NP stack and DP data frame steps. Combine the PCA transform data PCA underscore data with the label 1 into final data. Convert the final data into the pandas data frame with the columns. First principle, first PCA component, second principle, second PCA component, label, corresponding digit labels. Create the scatter plot using Seaborn where x-axis first principal component, y-axis second principal component, hue colors data points by their label digit, adds the legends to differentiate the digit cluster. Purpose of the code. Dimensionality reduction reduces the 784 features of the MNST data to principal components while retaining most variants. Visualization. Display the data in 2D space, making it easier to interpret cluster based on digits labels. Understanding PCA. Demonstrate how PCA transforms high dimensional data into lower dimensional space. This code is an excellent example of pre-processing applying PCM and visualizing results for data analysis and pattern recognition. The key outputs data set shapes original data after dropping the label column, the PCA transform data 2 and 1000 final data set with label 1003 plots, random image visualization, grayscale 28 into 28 matrix, PCA scatter plot showing cluster of data points based on their labels. Purpose. This code reduces the MNST dataset dimensionality for better visualization while preserving critical information using PCA. The finer scatter plot demonstrates how well PCA separates data points based on labels in the reduced feature space. This code demonstrates the workflow for the dimensionality reduction and visualization of MNIST dataset.